We are ready to begin the international webinar, Mathematician in Big Data, Aiming a Career of Data Scientist or Data Analyst. This webinar is organized by the Department of Mathematics of Mara Athanasius College. Mara Athanasius College is an autonomous institution in Kodamangalam in the Ernakulam district of Kerala state in India. The speaker for the day, Dr. Norma Elias, the principal of our college, Dr. Shanti A. Avra, the head of the Department of Mathematics, Dr. Rajesh K. Tumbakara, the moderator of this webinar, Ms. Marina Wilson, other faculty members and participants from abroad and India are joining. Due to constraints on the maximum number of participants that can be accommodated in the Zoom platform, we have our participants attending the webinar in YouTube live streaming also. Let me take this opportunity to welcome each one of you. The speaker for the international webinar, Dr. Norma Elias, Associate Professor in University of Technologies, Malaysia. As Madam will be introduced in detail by the head of the department, I brief and pass on to the next person. The principal of Mara Athanasius College, Madam has kindly consented to attend this session. And the head of the Department of Mathematics and all the participants from India and Malaysia, a very warm welcome to each one of you on behalf of Mara Athanasius College. I wish you all a great, useful time learning on the career opportunities of data analysis. Please note the following. Kindly mute your microphones during the entire length of the presentation in order to avoid background noise. Your queries on the topic will be settled at the end of the session. You can post your questions through chat box. The e-certificates will be issued to the participants who attend the entire session and complete the feedback form at the end of the session. The link will be provided in the chat box and will be available only for stipulated time. The schedule for today's webinar will be as follows. The principal of our college will address the webinar. It will be followed by the introduction of the speaker by the head of the department, Dr. Rajesh K. Tumbakara. And after that, we can listen to Dr. Norma Elias on data analysis. Now, I welcome the principal of our college, Dr. Shanti A. Avra, to address this webinar. Over to you, madam.
Thank you, Dr. Susan. Am I audible?
Yes, ma'am.
Okay. Yes. Respected Chief Guest, Dr. Norma Elias, Associate Professor, Technological University, Malaysia. Dear Dr. Rajesh Tumbakara, HOD in Mathematics. Other organizers and participants. Good evening and heartiest greetings from Mara Athanasius College, Kodamangalam. It is indeed a great honor to be with a distinguished academician like Norma Elias, Associate Professor of Parallel Computing, Technological University of Malaysia. I still cherish the memories of the last international seminar in nanomaterials when she was physically present here. We are very happy to have you with us again, Professor. Today, the Postgraduate Department of Mathematics begins the international webinar on Mathematician in Big Data. I congratulate the department on organizing this and inviting Dr. Norma as the keynote speaker. We are a nationally accredited A+ grade institution in Kerala, established in 1955 under Mara Athanasius College Association. The Department of Mathematics is one of the oldest departments in our college that has been committed to sustained excellence. The department is rich with academic milestones and endowments for the needy. It is the collective hard work of the staffs and students that has been taken to the department to new heights. In this organization and across our profession, the COVID-19 pandemic has promoted new ways of doing things. It was imperative that Mara Athanasius College reinvented itself with a digital agenda. Webinars like these thus improved our quality of knowledge, consumption, and dissemination. I hope this webinar will launch our students into the types of big data analysis. Moreover, the career prospects that will be discussed on the second day of this webinar is sure bring clarity and perspective to students. I once again kvetch my gratitude to the coordinators, especially Dr. Rajesh Tumbakara and Dr. Susan Ray Joseph, and others and faculty of mathematics. I wholeheartedly thank Dr. Vinny Varghese, our Honorable Secretary of Mara Athanasius College Association, for the encouragement and moral support for the program. I once again welcome Dr. Norma Elias and other participants, and best wishes for the 2 days webinar. Thank you all.
Thank you very much, ma'am. Thank you for the nice introduction. Thank you so much. Now I welcome the head of the department, Dr. Rajesh Tumbakara, to introduce the speaker. Over to you, sir.
Good evening, ladies and gentlemen. This is really a fascinating moment of joy, proud, and thrill for we people of Mara Athanasius College. We are really privileged to have with us Professor Dr. Norma Elias, Associate Professor, Department of Mathematical Science, Technological University, Malaysia. She has also worked as Associate Professor and Research Fellow at King Said University, Saudi Arabia, and Associate Research Fellow of Ibnu Sina Institute of Scientific and Industrial Research, Technological University, Malaysia, for long 12 years. Dr. Norma has a diverse field of specialization, including mathematical modeling, big data simulation, industrial computing, scientific computing, high performance computing, shared distributed parallel computing system, grid computing, and software development. Dr. Norma has supervised for 13 PhD students and is currently supervising 8 PhD students and 2 postdoctoral students. Also, he is supervising more than 60 MPhil students also. She has more than 200 indexed publications in international journals and is the editorial board member of 8 international and national journals. She is also visiting faculty of various national and international universities and keynote and plenary and invited speaker for various international conferences. Dr. Norma is also an active innovator. She has earned 2 product patent disclosures, 4 intellectual property declarations, and has won 16 medals in product innovation. She has received the UTM Service Excellence Award in the year 2016 and the Venus International Women Award as Distinguished Woman in Scientist for her achievements and contribution in the field of industrial computing for the year 2016 and 2017. She is also the principal researcher and leader in Grid Computing Lab, Mathematical Parallel Software, Multi-Core Computing Laboratories, and CPU, GPU, NVIDIA systems, and about 60 national and international competitive research granted major projects are ongoing under her project leadership. So, ma'am, it is really a great opportunity for all of us to hear from you, such an eminent resource person like you, on behalf of Mara Athanasius College and all the participants, I invite you to take over this section. Now over to you, ma'am. Also, I welcome Ms. Marina Wilson to moderate this session. Welcome, ma'am.
Thank you so much, sir. So, Dr. Norma, shall we begin today's session?
Okay. All right. Okay. I start the session. Okay. Do you hear my voice? Okay. I hope you can hear my voice clearly. All right. I share. Okay, my screen here. All right. Let's share screen. All right. Okay, thank you very much. Okay, the principal, Dr. Santi A. Avira. Okay, thank you very much for inviting me. Thank you very much to Dr. Rajesh, okay, as a head of department. Okay, the chair, Dr. Susan Ray Joseph, and also the moderator. Okay, the moderator is Dr. Nina. Okay, Marina. So I continue my session. Okay. This session is about mathematician in big data aiming a career of data scientist and data analyst. All right. So thank you very much, Department of Mathematics, Marathanesh College Autonomous. Okay, Kota Mangalam, Kerala, India. Okay, this is my third time, third time come to Kerala again, but this time is a virtual. All right, the best place in India. All right, I still remember. All right, staying in the Kerala for 2 times invitation. All right, so this is okay. I admin all the participants here. All right. So now, okay, I would like to share with you, okay, my, okay, let's go to all the participants here, right? So okay, okay, I'm okay, all right, to make sure that we can communicate, all right, in smooth. Okay, the moderator, Dr. Marina, okay, Wilson, okay, the chair, Dr. Suzanne, okay, we are meet again to talk about how the importance of mathematics, okay, to build a new career, a very good prospect career. We call as a data analyst and data scientist, right? This is okay, the first provocation for me to you. I hope all of you can scan, okay, using your handphone or write, okay, the information at the chat, right? So it's very easy. If I can write this at the chat, I copy paste, okay, Control C, and then I go to the chat and I paste at the chat. All right, okay, you can click at the chat or you can go for the scan. Okay, you can scan the information. Let's I enter. Okay, you can click there or you can scan the QR code. All right, so just a provocation, okay, about 3 questions, okay, through the Google form. If you can answer, I'm very proud. And then we share the outcome, okay, based on this voting, based on this survey. All right, so I hope you can scan or write or click at the chat, okay, at the chat room. Right, the same time I'm admin a few participants here, right? So you can go to the chat or you can scan. I give you a few minutes and then try to answer the question. There are 3 questions and then I'm waiting you at the Google form, all right? And we'll share with you the outcome of this survey, all right? I give you a time. Okay, the question is very simple. There is no true and no false. You can answer based on your understanding about data. And then we also know that the new career for mathematician nowadays is a data analyst and data scientist. And then also I'm asking about data leakage. Okay, data leakage, how you protect the data leakage, especially when you deal with the education 4.0 tool. Right. So now let's continue. Okay. All right, so this is a UTM. Okay, there are two important places. Okay, the branch at the Kuala Lumpur. Okay, is near to the tower, Twin Tower in Kuala Lumpur. It's very near. And then if you want to further studies, we'll come to University Technology Malaysia. And we also have another branch, okay, in Johor Bahru, which is near to Singapore. It's around 20 kilometers to Woodlands, Singapore. And we also have another branch at Pagok, which is a center between Kuala Lumpur and Johor Bahru. All right, it's around 150 kilometers from Johor Bahru. All right, so the business core for my university, University Technology Malaysia, is based on education, research, okay, because we are a research university status, and the services, all right, nation building, wealth creation, and universal peace and prosperity. So this is our business with the support by 7 faculties and 5 research entities. Okay, I'm under research. Okay, before this I'm under Research Institute, Research Center, but now I'm joining the faculty and the mathematics department. Right. All right. So now, okay, we have many students from many countries. All right. So you can see here, this is our lifestyle campus, especially during the COVID-19 pandemic. Everything's in virtual, everything online, everything deal with the system, apps, and software. All right. So today I'm going to share with you, okay, in these 2 days. The first day, I'm focused on the mathematics for big data. All right. I'm going to explain what is a big data analytics, okay, big data analytics, and then the platform to support a big data. And we are, as a mathematician, statisticians, okay, computer science, how, okay, we have a potential to groom, to create a student, be a data scientist and data analyst career. Okay, this is our aiming career, and then there's some conclusion. The next day, okay, we are going to continue about how to develop, how to groom, how to, okay, make sure our student, okay, be employed as a data scientist and data analyst. All right. So now, okay,
Okay, ma'am. Dr. Norma, can you hear me?
Yes, very clear.
Okay, ma'am. So today our topic is on big data, and a lot of our participants are undergraduate students and they're not much familiar with big data. So it would be great if you could start by explaining to us what big data is.
All right. Thank you, Dr. Marina Wilson. All right. So to answer your question, what is a big data? Okay, in my research, I'm using data, okay, generated, or I get the data from industry or from faculties, all right, and then from others in manufacturing process to visual, to do a visualization. I can do the visualization of the location, temperature, behavior changes, all right, the heat, okay, at the area, specific area, for example, face, brain, all right, and then the ice melting drastically happen in the world, especially at the Antarctica region, all right, and then we can also, okay, develop, okay, a very good visualization based on the mathematical modeling and data collected, okay, to do a prediction, and then to do the monitoring, observation, and then we hope that the data will give a good, okay, and accurate prediction. That's we want. All right, so I'm using data to do the 3D multi-dimensional visualization based on the mathematical modeling. And I'm also collecting data and then compare with the model that we get from the mathematical modeling. Nowadays, nowadays we are in the fourth industrial revolution, all right, where the people looking about the data, cyber physical system, which is full of data, okay, terabyte, gigabyte, byte, so many processed to controlled by the computer-based algorithm, all right. In nanotechnology, okay, the process of calculation is up to 10 power negative 9, very, very small, all right. So we need to do, okay, the process of training and testing data using artificial intelligence, all right. And then in biotech, okay, we always use image processing to do the observation, okay, investigation and so on. So the aim is for the predictive analytics, all right. So 3D printing, okay, blockchain, drone, okay, whatever the data generated based on these activities, they will create, okay, too much data, terabyte, okay, gigabyte, yottabyte, okay, the maximum, okay, value of data. So in this case, okay, whatever you do now, there is a digital transformation. Okay, look here. All right, you look here how the drastic, okay, transformation, okay, how the data collected very, very fast, okay, from 2019, 2020, now to 2021. Okay, we are in the COVID-19 pandemic. The data generated, okay, 2020, you can see Facebook, okay, before this 1 million, now 1.3 million. All right, for 2021, much, much more. All right, and then you also quite, okay, active in using WhatsApp. Okay, WhatsApp, you can see here, before 2019, 41.6 million. And then now people use WhatsApp to send a message, okay, increase up to 59 million, almost 25%. All right, you're quite okay, active using Instagram. Okay, Instagram, you can see here, all right, from 400,000 to 700,000 approximate. So this is very drastic, okay, using the data, many types of data, increasing very fast. So people looking to analyze data, okay, system of the developer looking how to analyze the data. All right. Okay, what is a big data? Okay, before this, okay, we categorize the data into three: volume, variety, and velocity. All right, only three types of the category of data. However, okay, nowadays, okay, people looking 7 types of big data, not just a volume, variety, and velocity, but they're looking for the value, visibility, viability, and veracity. All right. So you know what is a volume? Okay, data generated based on the mega, giga, tera, petabytes, okay, yottabytes, and so on. Okay, based on the volume. All right. However, variety is how much, okay, how much fast the data, okay, generated based on different types of data. For example, okay, here we are looking for the voice. You are here, my voice. You are looking my video, okay, my photo. And then there is images, okay. Also, we have many types, for example, weblog and streaming. Okay, we are now, okay, online streaming, okay, using YouTube. So you also, okay, now, okay, the administration generate the data very fast. And then the last is a velocity. Velocity is how speed the data every second, every minutes, every week, every month, every year. All right. And then the value is how the data performance, okay, how we can analyze the data, matrix the data, and how the data driven, okay, for its performance. For visibility is more on the clarified attention and prominence of the data. All right. Variability is okay, we want to find the predictive analytic. We want to predict the outcome. So how the variability the data to predict the specific, okay, observation, all right, prediction, and then the monitoring. And then veracity is how messy the data. Is it full trusted data? Okay, the data is a qualified, okay, there is a good quality and accurate to predict. So this is a 7 types of the data. All right, so I'm looking for the volume of data. That's why, okay, that is deal with the big data, and I'm solving the data using big data analytic or statistical approach, or develop a mathematical modeling to classify the data. All right, so this is a basic information. And then, okay, when you can see here, there is 2 types of data. One is the type, okay, the category of data is a structured and unstructured. All right, so now I love if I can, okay, differentiate between, okay, I admit all of you, all right, so between the unstructured data and structured data. Unstructured data is like video, okay, what we have now, streaming, audio, okay, email is unstructured data. The structured data is like numbers, okay, dates, string, all right, so you can differentiate, you can see very clear. So we can also display in a row and column in matrix form and so on. However, unstructured, okay, you cannot display in row and column. So this is a type of data. Okay, we hope that we can able to differentiate after this. Yeah.
Okay, ma'am. Thank you. So, ma'am, that now you talked about big data. So, could you elaborate a bit more on how this data is generated? How big data is generated?
All right. Okay. Okay, I love if I can go to this okay, video. Okay, I share, I'm stop sharing. Okay, I go to this video. All right. Okay, now I start. Okay, you know that, okay, data generated, okay, is come from 20% come from the individual, from you, from me, all right, using handphone, using computer, using laptop, iPad, notes, and so on. So the data, okay, comes many types of data, images and everything, okay, that will be exabyte, okay, so many data, and then it's not, okay, it's not, we cannot, okay, put in the drive. It's not in drive, okay, in the drive, but we can, okay, now using cloud. So we are looking the data generate very fast per minute on the internet. For example, Facebook, I told you, all right, million nowadays, okay, YouTube, 4.5 million generated, all right, you also create a YouTube. Now our session also in the YouTube streaming, so we generated the data. All right, so is it possible, okay, 5 concept, okay, we generate maybe based on the volume, velocity, variety, okay, veracity, so 5 types, okay. All right, so now as you know, volume is based on the how many bytes data, giga, iota, zeta, okay, penta. Velocity just now, okay, how speed the data, okay, develop a cloud, okay, for example here between the patient and their result. And then variety just now is I told you, structured and unstructured data, or semi-structured, all right. Structured data, for example, the OC file, Access file that you're using, okay, and then the veracity, how accurate the data, how trust the data to be do analyze, training and testing to predict something, all right. The value of the data, okay, whether, okay, you can reduce the cost, okay, you can do detection, okay, prediction and so on. So in this case, all right, there are a cloud, okay, that provide you to save the data, to keep the data, all right. So I'm stop sharing, I'm go to my PowerPoint again, all right, to generate, okay, to explain how we generate the data. All right, so now, okay, in one, okay, business, okay, this is a production cosmetic industry, biotech cosmetic industry in Malaysia. Okay, they can create 4 trillion sample of the cosmetic based on the biotech technology, all right, to be analyzed almost every year. So how fast, okay, the cosmetics, okay, factories here generate data every year, all right. So the problem here, how we can look, how we can monitor, how we can track whether the business is a good or bad. So this is our intention now. Even though most of us here is a lecturers, a student, all right? So we generate a data almost every second in Educator 4.0. Okay, we are using the future ready education software, for example. Okay, in our case here, we are using video conferencing, we are using streaming, we are using Zoom, we are using YouTube, all right? And in class, we are using Google Meet, all right? And then we create the data based on the WhatsApp, chatting, Telegram, and other social media. All right. We do interactive presentation now. We are doing interactive presentation by using, just now I'm using Google Form. Maybe I'm using Padlet. Maybe, next time I'm using Mentimeter and so on. So we are generating a data. Okay, screen record is one of the important, where we are also create a data in the education 4.0, all right? But now, we want to analyze the data, whether, based on what we do in the class. For example, we have a data in the quizzes, in Kahoot, in Nearpod, Coursera, Padlet, Propose, Quizlet, and other questions that we post in the Education 4.0 software, and then we can analyze, whether, the analysis, give a good impact to our teaching and learning style, whether, students have a good impact in terms of the confidence level to the IT and cyber technology, for example. All right. We also expose the student all the category, for example, the tool, the process of the delivery, knowledge sharing, the social media to support, our data, and then we create a cloud, using the many types, for example, the cloud for Facebook, a cloud for YouTube, a cloud for the learning management system, and so on, all right? So we hope that, this is a open, a new business and new market who are people, expert in analyze the data, all right? So now, what we do now, is we do a transformation from small data to big data, all right? Before this, we are using a gigabyte, terabyte, and then byte, very small data size, all right? We are using a simple programming with using a simple tools, a simple software. But now, people looking for the big data, for example, the volume like peta, zeta, exabyte, all right? So this is a deal with the complex system. For example, we are mathematicians, we are statisticians, we are computer science. Before this, we are using a small scale of the experiment. Now we are using a large scale, complex scale, all right, many parameters, many variables, independent and dependent variables. All right, in statistics, we have so many dimensions to us. There are so many factors to us, all right? So we deal with a large, large sparse simulation, all right? And then this large sparse simulation support by the large memory architecture, all right? When we deal with a large memory architecture, we have two types, First, a distributed memory architecture, and then the other one is a shared memory architecture. So what we do now, we are using computer that is a one CPU that is we call just one CPU or shared architecture, all right? So to make it more performant, we join a number of CPU, a number of computer, a number of server to develop a distributed memory architecture, all right? At the same time, we are also using cloud, all right, to save our data, to do the communication between the data, to do a data transfer, to collect the data, and then to analyze the data. So to do the distributed computing, we need to have a communication architecture. So I know this is too far for the mathematician. All right. So you can, the important is we want to see the impact. The impact is, you know, as a mathematician, your modeling, your simulation, your prediction using statistics or mathematics is much, much more accurate. All right. The real-time observation can be done because, okay, the process is on the huge memory, on the distributed memory, on the shared memory architecture. All right. And then the data, okay, the prediction, okay, very accurate, a very precise negotiation between the practical and the analysis, the practical and the analysis. All right. So we want a good impact for our research. All right. So what is the task as a mathematician? All right. You can see here, I make a circle 2 column. All right. So you can see how important mathematics, statistics, okay, to do a decision support for data science. Okay. The data is come from data engineering. It's come from your handphone, your device, all right, your sensor, all right, and then whatever things you have, okay, you generate a data. That's we call data engineering, all right. So then the data analyzed using the, okay, based on the data, we call it as a data engineering, and then data analyst, and then data scientist, okay. So there is a data science to be analyzed, and then this is a function of mathematician because they are very good in develop a model. They are very good in prediction. They are very good in statistics. Okay, they are very good in some software to support their prediction with the technology. Technology here is a software. For example, you are using SPSS, you are using Amos, you are using MATLAB, you are using Mathematica, Maple, and so on. All right. So now, okay, based on this analysis, okay, they can make a decision making. In this, okay, we need to have the communication skill with the business people, with the computer science people, because we want to develop a system, all right? This system easy for our customer to make a decision, okay, to do some, okay, modification of the data. So you can see here how important mathematician and statistics to support the prediction, okay, the observation, the analysis of data, right? So now, where we are, okay, we are small portion, but okay, we are expert, okay, in the math, statistics, and the provider, algorithm provider, okay. We can, okay, groom, we can curate, we can make the student, okay, with this new career, data analyst, data scientists, and data engineers, all right? With the, okay, people from computer science, very good, okay, in develop a software engineering, very good to handle the communication between the servers, between the processor, between the GPU, CPU architecture, but there is a data modeling, okay, there is what we call as, okay, scheduling process or data modeling to support the data scientists. You can see here, all right? So I circle 2, okay, one is a data analyst, and then the second is a data modeling. We are quite expert, okay, to model, okay, develop a mathematical model based on the data given, all right, based on the data given. All right, so now you can see here, okay, there are 2 x-axis and y-axis here, 2 lines. Okay, one is a business value, okay, the impact, good impact. The other one is a complexity, all right? So I love if we focus the artificial intelligence here, okay, the green color, all right, machine learning and predictive analytics, all right? Okay, to do that, okay, with the complexity, I know, okay, we are very expert in statistic modeling, all right, forecast, and then multivariate. We know how to do, okay, we can predict many things about the distribution, okay, data distribution, everything. But the important is, can we do a prediction based on the data? We call as a predictive analytics. Can we do a train of the data and testing the data? That is a question, all right? And how we can use the classification okay, method based on the machine learning, for example, neural network, okay, artificial neural network, support vector machine. Okay, this is a method, okay, to train and test the data. All right. So towards the end, we want to make a decision where we call is artificial intelligence. And then that is important because, okay, we want to run anything, okay, what we have, for example, in industry based on the automation robotic, okay, automation robotic. All right, so this is a spectrum of the data scientists. Okay, we collect the data and we start communicate with the machine using Internet of Things, IoT. All right. We also need a data to develop a smart city, smart classroom, smart education 4.0. So this is very important about the data. All right. So you can see here the high knowledge in the field of data science is what? Is again mathematics and statistics knowledge. And then hacking skill. All right. Okay, this is very important because, okay, during the COVID-19, everything virtual. So be careful. Okay, I asked you already the question, how you keep, okay, how you keep safe from the data leakage. All right. So, however, we need a machine learning, we need a data science, okay, to cover, to protect for the hack, okay. So this also develop a hacking skill, all right. The sustainable expertise, okay, this is very important because this is considered as a high knowledge of the data science, all right. Okay, so now, okay, I put two lines. The first part is a statistic. Okay, you know how to do stochastic, okay, forecast, deterministic. Okay, you are very good in doing this based on the data oriented. Okay, whether data is random parameters, whether it is a fixed input with a different output, with a fixed input, with the fixed output. So it's depend, okay, how you analyze the data. Okay, in this case, maybe you are using SPSS, you're using AMOS, okay, you are using SAS, SAS, and others, all right? So the other part is a mathematician. Mathematician, they love to develop a model, okay? They get the parameters, independent and important parameters, controllability parameters, all right? They do the continuous time or discrete time, okay? And then we do the model where the dynamic or statics, okay, description at the one point at time. So you can use, if you, for example, if you're using partial differential equation, you can use, okay, elliptic equation, parabolic equation, or hyperbolic equation. It depends on the application problem, all right? So now, okay, however you create a data, okay, you do mathematics modeling and simulation, you develop a large sparse simulation, all right. To solve a large sparse simulation, you cannot afford by using one CPU, one laptop, because the data is very huge. It's a terabyte, all right. All right, so pentabyte, so zettabyte, exabyte. You can't use one CPU. You need a server, you need a cloud, you need a parallel computer system, or we call as a distributed parallel computer system, where you merge a number of computer, develop a huge memory and very good speed of the simulation. All right, so the simulation you don't to wait, but a few seconds, okay, the simulation will be completed, all right? So this, we need HPC, high performance computing, and then we do the verification and validation. Okay, we are using a validation and verification, all right? So now, let's go to the next step is a prediction and the visualization. This is our aim, to do the prediction and the visualization, all right? All right, so now, okay, people always say that where the data, all right, from where the data comes in, okay, the source of data you can see here is a smart grid, smart sensor, medical equipment, for example, MRI, okay, CT scan, and then mammogram, ultrasound, all right, digital camera, GIS, okay, FEM, SEM images that you can go to the chemistry lab. They bring you the nanotechnology images, okay, up to the 10 power negative 9 machine and meter. That is a data come in. Okay, most of the data come from the satellite images and then the sensor. All right, so you have to know that the data can be categorized as a structured and structured, okay, with the 7, okay, volume, velocity, variety, all right, the value of the data, and then we need to have a high performance or the supercomputer to support the simulation. And then in this case, you need to learn something about the communication protocol, the software to support the message passing between the data. And then the last is an extension of the data, whether you want to do the derivative, a good enhancement, okay, derivative, a good discretization, okay, and increase the dimension of space and time, okay, the behavior of the data, whether you want to modify, okay, all the boundary condition, initial condition, all right? And then in this case, maybe you need a statistic or numerical method to support, okay, to analyze the modeling and simulation, okay? All right, in this case, okay, we need to integrate with the numerical analysis, yeah? All right, so now this is one example in my lab. Okay, I'm using MPI, okay, CUDA. I'm using PVM to support the shared and distributed memory architecture. All right, because the data is too big, so we need a platform. If you don't have a platform, don't worry, you can go to the cloud. All right, nowadays people looking for R, Python, Scilab to do the machine learning process. Okay, so this is open source. Okay, others in the numerical, okay, or in the statistic, you can use C, you can use SPSS, all right, and then you can also use CUDA, Console Multiphysics to do the visualization, very good visualization, all right, and then multidimensional visualization, and Luna. Luna is a for the specific application. So there are so many, don't worry, it depends on the what is the application that you want to solve, all right? So the next is maybe, okay, which is not compulsory, okay, since you're using, okay, high performance computing, you need to know how to do a mapping between the tasks, all right? You need to design the domain partitioning, because the data is a domain. So how you partition the data into a number of processor, into a number of memory. So this is another skill, all right? Based on the skill, you can see, okay, you can design a good communication between the tasks, between the processor. So the design or the scheduling, okay, is one of the skill, okay, is considered important when you run the problem in the parallel computer system. All right. So now, since we are mathematician, okay, we are dealing with a complex model. Okay, what is a complex model? Okay, the complex model that we assume here, all right, is based on the how you do the modeling and then how you do the simulation of the model. Right. The important is we want to merge to the reality. Okay, in this process, okay, to merge from poor approximation to the accurate approximation is based on your knowledge, okay, your ideas, your concept. There are so many concepts. Okay, the important is we need to make sure the method is the model is a stable, okay, accurate, consistent, unique, converge, and so on, right? Even though in statistics, okay, whatever model that you want to develop, it should be predictive, okay, it should be predictive. All right, so now, I think Dr. Marina, okay, need to know, okay, what is the example that I implement in our lab, all right, for the big data analytics, yeah, Dr. Marina, yeah, all right. Okay, one of that, since I'm dealing with the multi-nano scale, okay, since I'm dealing with the very small scale device, for example, handphone, okay, the data is very, okay, the device is very small. It's a multi-layered Okay, it's a multi-layered system. It's a multi-layered. So, okay, to do a model also, okay, it's not easy. Okay, we need to do a multi-layered boundary and initial condition. All right. So this device, okay, you can see your handphone. There is no wire. Okay, all in the platform. Okay, what we call as a nanoscale device with the semiconductors. Okay, and then the device full of the silicon, metal to do the heat transfer, to do the thermal conductivities, to send the energy, the power for one device to another device. All right. So this is one of the complex model that I can show as a one of the example. And to do this, we are using partial differential equation, right, to draw the specific area, okay, because this one is a 3D. We want to find the temperature distribution, the volume power density, the thermal conductivity. So I'm using Poisson equation. I modified the Poisson equation, and then they will create a large sparse, okay, simulation, okay, using numerical method. Okay, numerical method, there are a few methods here. Okay, for example, that you learn in degree, okay, is like Gauss-Seidel method, Jacobi method, okay, direct method, Thomas, okay, or Lagrange interpolation, Lagrange method. So I'm using AGE method, alternating group explicit method, and red-black Gauss-Seidel, because the data should be run in parallel. All right. So we can see here, okay, another research in silicon nanoneedle. Okay, silicon nanoneedles means that we develop the silicon nanoneedle using chemical vapor deposition process, or CVD. We are using CVD to grow the silicon nanoneedle, okay, to develop the platform, the motherboard of your handphone, which is no wire, but we develop the silicon nanoneedle. We grow the silicon, all right, in term using the CVD. So to do this, okay, I'm also using parabolic, okay, one of the partial differential equation, parabolic equation, to represent the way how, okay, the silicon growth at the motherboard of your handphone. All right, so this is what we do. It's still under nano technology, because CVD is dealing with a nano needle, very small wire. All right. And then the third, this is very important nowadays. Okay, we not just focus on the developing the model. We not do the data modeling, okay, data simulation, but we are dealing with the real data, okay, from the electroacoustiography, or AEOG or EEG, where the data is a wave. For example, okay, how my eyes look, okay, how much time I spend, okay, or how much time I can look at the computer, drive, okay, focus driving, and then there is a sensor I can put around my eyes, okay, and then you can see the muscle stress, muscle strain around my eyes, okay, and then I can predict when I start, okay, tired, the eyes tired, where you start stop, okay, do programming and so on. So this is we call as a detecting eyes muscle stress problem, eyes movement left and right problem. All right, so in this case we put the sensors and get the graph of the EOG, and then we analyze, we transform the graph to the digital. In this case I'm using MATLAB, and then, okay, because the data is very huge, because the data generate every second, so I need the high performance computing system to support the large sparse simulation, and of course the platform high performance computing should be have a large memory architecture. All right, so you can see my result, okay, the graph, okay, the wave will be, the frequency is very low, meaning that the eyes movement, the eyes stress is become worse, okay, for a certain period. All right, so now maybe, okay, people asking, okay, asking us. All right, so maybe
Ma'am, can you explain about the performance evaluation comparison about this big data?
all right. So now, okay, Dr. Marina, okay, request, how they perform, why we need to do the research, and then how we want to analyze whether the research is correct or not, how the prediction, okay, how we want to do the performance evaluation with the specific indicator. So that is in our mind, all right? So we have so many ways to analyze whether what we do is correct or not, whether what we do is a very good in the performance, in the measurement performance. So in this case, all right, we are using a few indicator. For example, the speed up. All right, when we do data simulation, data analytics based on the Terra, Giga, all right, Penta, Zeta, Eva, Iota guide, byte of data, you can see here, the indicator like speed up, how fast, the simulation ends. So that's we want. The speed up is a time for one processor to divided by number of processor. The efficiency, the effectiveness, the temporal performance to compare a number of method. So this is in this when you deal with the mathematical modeling and simulation statistic, you need to compare with the some method. So temporal performance is one of the indicator to compare between the methods, and the granularity. Granularity is how much, how the ratio between the computational and the communication cost, all right? So now I compare a few platforms, because since in the lab there are so many platforms. There is a GPU platform, there is a MATLAB, there is a distributed architecture, there is a hybrid architecture. I compare. From the comparison, you can see here, all right, the graph is increasing, the speed up is increasing, the run time, is increasing, all right, when the data increase. For example, here, 128 times 128 times 32 is a very huge data compared to the small data, 16 times 16 times 4, all right. So you can see here, the performance is increasing. However, based on this experiment, the speed up is like curve. It's like curve here, increase and then decrease. Why? Because the data is too small. Second, the communication, the process, the process of sending and receiving data is too much. So it's not relevant. It's not relevant. How to solve this problem? All right, we are going to explain after this. All right, when we use a MATLAB, I know you are a mathematician, you are quite expert in MATLAB, this MATLAB software, you are expert in Mathematica, and also you are expert in C programming. When I'm using MATLAB, since this is based on the library oriented, the graph is slow, the performance is very slow compared to other method, other communication protocol, for example, PVM, Parallel Visual Machine, the speed up is very good because they are not library oriented. We are integrate PVM with the C program, C language, and we do the programming. MATLAB is a library oriented, so the sending between buffer and buffer, library and library will impact the communication cost, all right? And then I'm also using OpenMP. Some of you are from computer science, you are familiar with the OpenMP based on the multi-core, processor, all right? So I'm comparing, between the MATLAB and multi-core OpenMP. It shows that, all right, the OpenMP is much better compared to MATLAB. All right, why? Because OpenMP is a communication between buffer to buffer, and then they can adapt, the high granularity problem. All right. So the third is comparison between methods. This is a common. In mathematics, in statistics, we compare the method to see that your method is a superior. Even though in the big data analytics, we compare a method based on the number of classifier method, right? Classifier method, for example, KNN, SVM, genetic algorithm, or extreme learning, iForest method, and so on. All right. So now, okay, maybe Dr. Marina Wilson, okay, want
Yes,
to
ma'am.
answer me about the tool? Mhm.
Yes, yes. So, what is the tools to support big data simulation? So, we spoke about big data and everything. So, what are the key elements in that, the big data simulation? Can you please speak about that?
All right. Okay. Okay, Dr. Marina, I mean, okay, people here. All right. So the tool here, I means that okay, hardware, software to support a big data simulation. We are not talk about the okay Giga. All right. So let's we go to the okay. All right. Okay. We stop for a while. Okay. We not just focus on the hardware, software, all right? But we also focus on the cloud, the size of data, the variety of data, the types of data, okay, the structured and unstructured data, the supervised learning, unsupervised learning data, the labeled and unlabeled data. So this is a question from the student, all right? This question from the student, they said that how big the data? Is it 100 megabyte is considered big data? All right. And then how to get the data? Is it from the IoT? Is it Internet of Thing? All right. So this is a question that you can read here. Is it RFID also implemented, okay, to create a very good big data? So this is a question that I can okay answer. All right. After this, okay, the important is okay people now looking for the big data. It's okay, not a small data for the accurate prediction, for the accurate monitoring, for the accurate observation. All right. So when we deal with the big data, the tool okay, keep in your mind is a skill to do the parallel processing. All right. How to do a parallel processing? You can see here. Okay. Seeing serial. Okay. What you do now. Okay. In your computer, in your laptop, in your programming. All right. In the software that you use is a serial or sequential processing. So meaning that okay, first come, first serve okay, in the sequential manner. However, in the parallel processing, you have so many tasks, so many colors here. Different colors, different tasks. Okay, different colors, different processor. Different colors, different memory. And then we join again to get the overall result after the process of, for example, big data analytics, training and testing the data. All right. So when we talk about the big data platform, okay, big data platform to support the huge simulation, okay, I can suggest here there is a SIMD, all right, and then MIMD, and also okay, okay, all right, MIMD, SIMD, MIMD, and SIMD. Okay, but my work is more on the single instruction multiple data streams, SIMD, single instruction, but many data, all right, to be solved. All right, so now, okay, so to do that, okay, the comparison between serial programming and parallel programming, okay, we have the same problem. Okay, the instruction is as in the sequential. However, in parallel, the sequential in the block, in the task, okay, in the parallel, in the synchronized, in the concurrent manner. All right, and then we post to a number of processors. Okay, not one CPU. We post a number of processor in your computer, maybe multi-core. Okay, in the GPU, CPU. Okay, they integrated between the thread and block and grid. All right, so this is terminology. All right, so now the journey here is you do the transformation from using one CPU to the number of computer, okay, to the distributed parallel computer system, and then nowadays the generation of computer increase, so you can use GPU, CPU, computer very easy get in the market. They will support you terabyte simulation, right? So the other one is a slingshot short packaging. Why? Because you can see the way they package, okay, is last time is a rack, very big rack. For example, at the back of my, okay, is a distributed paracomputer, is a big rack. But now, okay, the custom rack is just based on the network card, GPU, CPU, and okay, and then the cabling, sometimes the cabling can be supported by wireless, all right? And then you can see here the transformation from using one CPU, okay, one processor, to the high performance computing, with the high performance computing platform managing, okay, not just a platform only, but how we manage the data, and then how we make a high performance computing as a cloud, what is a cloud? Cloud is a data that you send, okay, to a specific area, is based on the very high performance computing system there. For example, YouTube, okay, you send at the cloud, all right, and then for here you are using Zoom, they zoom the data at the using Zoom cloud and so on, all right. So you can see here, when we talk about the big data analytics, okay, when you do a testing and training, all right, you need to, okay, get some information about the programming, not just a mathematical modeling, not just the performance indicator, not just how to create a new or enhance, okay, programming, but there is integrated, okay, programming language you need to know. Okay, nowadays people looking for R, Python, okay, and then C++, okay, and then Scilab, Keras, TensorFlow, all right, because this is open source and support the machine learning, okay, big data analytics, and then predictive analytics, all right. And then the programming model here, okay, for example, OpenMP that I using now is a GPU, CPU. The environment is okay, I'm using high performance computing. Some of them using GNU, okay, GNU, and then some of you using the Cray, okay, Cray architecture, and then optimize the library. Okay, we have so many libraries here. You can choose. Since I'm using Linux, I'm using LabPax, okay, and Blast, and so on. All right. So the tools here is debugging, okay, debugging support, okay, the statistic, and then the how debugger that you want to support the huge simulation, for example, and then the analytics tool, artificial intelligence. Nowadays, so many MATLAB distributed computing is one of the example to support the big data analytics or machine learning, okay, architecture. All right. So now we don't want to go too much. Okay. However, I just want to share with you. Okay, Fugaku. Okay, they claim themselves as a fastest, okay, Japanese machine, up to 415 quadrillion computational, all right, to analyze the data from COVID-19, okay, pandemic. There are so many data. So they said that, okay, the Fugaku is a Japanese supercomputer, has been a world fastest nowadays. Okay, these are the latest computer generation to support the big data analytics. All right. Okay, now, okay, maybe you ask me a question. How big data analytics works? Okay, how is work? Okay, it's come from, okay, if you heard before this is a data mining. All right. You heard before this data mining. What is the advanced analytics process here? They can develop a search, okay, the pattern recognition, and then the relationship between the dimension, okay, the factors of data. All right. So now people, okay, shift to the pattern, okay, pattern recognition, and then the relationship between the data. The second is a predictive analytics. Very important. Okay, mathematician, they are quite familiar to do a forecast. Okay, they can do the prediction, okay, based on the data. And then, okay, the tool that we want to express here is a machine learning. Okay, why? Because machine learning with the classifier method, with their process of the feature extraction, pre-processing, classification, segmentation, and analyze, is a deal with to analyze a large data set. All right. And then the last is a deep learning. Okay, what is a deep learning? Is enhancement from the machine learning dealing with the real big data. Okay, real big data. All right. So now, okay, you have to know that, okay, this is when we do the data training, okay, for example, the basic that you know is artificial intelligence, artificial neural network, ANN, and then maybe you hear about the support vector machine, and then people looking for the genetic algorithm, all right, they're using also extreme learning, okay, nowadays is a iForest method. All right. So these are dealing with the data learning. Okay. And then, okay, we also have, divide the data into two parts. 85%, okay, at 75% for data learning, and then 25% for data testing. We want to merge data testing and data learning, all right, in the same curve, okay, in the approximation curve, all right. So to do a data learning, there are two types, okay. The first is a supervised learning. The second is a unsupervised learning. There are two types. I'm going to explain. Okay, supervised learning is based on the labeled data. Okay, and unsupervised learning is for the unlabeled data. So my question here, okay, what is a supervised learning? All right, all right. What is a supervised learning? What is a labeled data? All right, and what is the unsupervised learning? What is the unlabeled data? All right, supervised learning is not data oriented, it's a task driven. It's a task driven. For example, okay, when you have two types of tasks, you can differentiate the task between two groups. Okay, we call as a binary classification, two class. All right, and when you have so many tasks, okay, you can divide, okay, into three classification or multi-classification. All right, or you can draw a line between two types of data, okay, two types of data. We call it as a regression. This is how we do the classification of the data based on the supervised learning. Unsupervised learning is a data-driven. Okay, data-driven, for example, what? The unlabeled data. For example, okay, you know that the data that we are doing now is a streaming. There is a voice, okay, the frequency is very high, sometimes very low. So in this case, okay, we try to clustering the types of the frequency, all right? We try to do the anomaly detection of the data, and then associate mining, and the important is how to, okay, reduce the factors, reduce the parameters. Okay, we call as a dimensionally reduction, because the data, the frequency is based on noise, is based on the many, okay, parameters here. So how to reduce the factors, how to reduce the parameters, how to reduce the dimension of the data. All right. So now, when you okay, maybe Dr. Marina want to ask a question.
Yes, ma'am. Yeah, so we are running out of time, ma'am. So can we now move on to data analyst and data scientist? Like what
All right.
data scientist is?
Okay, very good. All right, very good. Thank you very much because reminding a time. All right. So, okay, you can read here between the labeled data and unlabeled data. We always focus on the labeled data. All right. And then for the image processing, that is considered as unlabeled data. All right. So this one is one of the example. So yes, Dr. Marina asking me a question. Okay, what is a data scientist? What is a data analyst? All right. So many questions. I received many questions. For example, okay, the question, okay, from student, how to become data analyst, how to become data scientist, because they know that the salary is very high. All right, you can see here. Okay, if I can share with you. Okay, okay, I'm stop sharing. Right, I want to share with you. All right, the one of feedback from my student. Okay, that's if I can go to the website. All right. Okay, I'm sharing this session, right? Okay, you can see here, okay, when I ask a question, I hope I'm sharing, okay, this session, okay. Stop sharing.
Yes, ma'am. Yes, ma'am.
Right. So now, when
Yeah,
I
yeah.
ask a question to the student, okay, they know, they believe that the data scientist is a very hot, okay, career nowadays, okay, because, okay, they deal with the, they can know that this data can improve their business, all right. They can, you can see here, okay, they can apply their skill in the university, okay, they, all right. So you can see here, I get this feedback from the student. Okay, okay, share this session. All right.
I am a Master by Research student under Dr. Norma and Prof. Tahir. And today I would like to answer a few surveys. So currently I'm working as a software developer in Billion Prima Sendirian Berhad. So let us start in answering the survey. So the first one, what is the responsibility of data analyst? So for me, the responsibility for data analyst is to extract meaningful information from the data that could be used in our daily operation. And the second one, what is required to become a data analyst? First of all, a strong knowledge, a strong background in mathematics, especially in statistics, machine learning, and modeling. And then the second one is a good understanding in programming knowledge, like R or MATLAB or Python. So the third one, what are the various steps in an analytic project? So for me, the first step is usually for us to clean the data, to get rid of the irrelevant or outliers, and then to analyze the data using statistical methods, and then to present the information that we extracted to the client. And then what are the top 3 skills for data analysts? For me is mathematical skills, statistical skills, and programming skills. How do you interest in this career as a data analyst? So for mathematician, there are not too many job opportunity, but one of the biggest is being a lecturer or teacher, and then the other one is to become a data analyst or a data scientist. So for me, the better choice is to become a data scientist. And then finally, what are your strengths in data analyst? For me personally, I think my strength comes from the strong background knowledge in mathematics. Okay, thank you so much.
So I was given a task by Dr. Norma to answer these questions about data analysis. So for the first question is about the responsibility as a data analyst. So for me as a data analyst, we need to get involved in all the process from retrieving the data, until the analysis part. So from the analysis part, we can give meaningful conclusion, and then we can give decision from the analysis. Okay, and the second question is that what is the requirement to be a good data analyst? So to be a good data analyst is that someone must have a good mathematical or statistical skills. Besides that, what is important is that they must have good coding skills, for example, Python or R or MATLAB. Okay, and another requirement is that the data analyst must have the ability to analyze and interpret the data.
All right. Okay. So this is okay, feedback from my student. Okay. They are all in the industry. They are all in the a company. Okay, investment company and so on. Okay, they earn a very good salary. For example, for my undergraduate student, right, they can get around 3,000 ringgit Malaysia, approximate to how much? 800, okay, 700 times 3 times 4, okay, 800 to 700 US dollar. All right, 800 to 700 US dollar. And then for my master student, okay, they will get okay, around 1,000 US dollar. And then for my PhD student is around okay, 2,000 ringgit, okay, 2,000 US dollar. Okay, so you can see that, okay, this is how they are very, very, okay, interest, okay, to do big data analysis, okay, analytics, and then they are doing programming, okay, they are doing the mathematical modeling and so on. All right. So now, okay, the next question, okay, the next question, all right. Can I look forward data analysts and data scientists post during the COVID-19? Yes. Okay. Okay. During the COVID-19, okay, this is the best, okay, way for you to make sure, okay, you can go to this career, you aim this career, okay, because you are expert in the mathematics, statistics, programming, computer science, okay, and then machine learning, deep learning, and others, okay, predictive analytics style nowadays. I have no exposure to programming. So can I be a data scientist and data analyst? So for me, yes, okay, yes, of course, because okay, as a mathematician and statistics, you are familiar with the statistic SPSS software, SAS, AMOS, all right, and then you also familiar with the MATLAB, Mathematica, Maple, okay. Okay, that's why I know you have a basic programming. Now is a time for you to make the programming exposed to the, all right, for example, nowadays, okay, people looking for R, TensorFlow, okay, and then Scilab, all open source software, all right. Do I have a computer science degree compulsory? No. Okay, no, all right, no need, but you need to know how to do programming. Okay, this is a very basic. Okay, now, okay, the second question, okay, here that I can put some example, okay. All right, well, what is the difference between, okay, data analyst, data scientist, okay, machine learning, operation, all right, well, the data engineers and so on. I can show, okay, as like this example, okay, one athlete, okay, they want to run very fast. What is the skill to win the competition, okay, to be a good in marathon, for example. So the first thing, okay, without any skill, he can capable to run the first part of the race, but cannot go further because there is no skill. All right. The second is he can race the entire lap, maybe half of the lap. That means they have a little skill to finish the lab, okay, the entire lab, all right. The third is they won't have a specific skill from the coach, all right. So they only can finish the second part of the race, okay. However, the last part, if we design a good shoes, a track shoes, a good coach, okay, to empower the other runners to race at the top speed, so I think he can win also. All right. And then the last, okay, the process should be in the cycle, because practice and practice should be done. So we bring all the team to the track meet again to finish, okay, to make sure, okay, all the athletes can be okay, winning at the specific race. All right. So when I compare with their, okay, activities to the, okay, what we talk now is aiming of our career as a data scientist, data analyst, or data engineers, or machine learning engineers, or machine learning operators. Okay, so this is our aims now. So we can say that data engineers, okay, their function is to collect the data engineering. It's come from any types of the sensors, meters, device, satellite, all right, data, raw data from the data questionnaire, all right, from the voting and so on. Okay, based on the data, there is a noise. Okay, there is structured, unstructured data, labeled and labeled data, all right. So we need to categorize. And then this is a function of data analysts. They are doing a data cleaning, they are doing a data processing, they are creating a final product like a dashboard. Okay, so my student always said that dashboard. I'm creating a dashboard report, transforming a data and then explore the data. The second is a data scientist. Data scientists are the important is they know how to do the predictive analytics, able to apply the statistic methodologies to create the complex, okay, product, to classify, to do a prediction, okay, to use a statistic powered model that we learned before, to do a data modeling, to do a data cleansing and preparation, and towards the end, a data analyst. All right. Next, the product, okay, the analyst, okay, give to the machine learning engineers. This is very important because they apply machine learning or deep learning. Okay, they apply classification, regression, all right, and then many types of the classifier method to bring start of art of the solution. This is very important because we want to do what this now? Prediction, observation, monitoring, and the data scientists able, okay, be run a big data using GPU, CPU based computing. This is very, okay, you need to do some programming, and then include a neural network. For example, you can use, okay, RNNN, CNN, okay, extreme learning, support vector machine algorithm, the genetic algorithm, and its transformation. All right. And then towards the end, the operation of the machine learning, they will create a model, okay, for users to get a real world classification or prediction. They do a collaboration, they do a communication between the data scientist and the machine learning operator or operation professional to manage the product of the machine learning life cycle, okay, because the company, they want the decision making. And towards the end, okay, maybe after dealing with this collaboration, they're using a metaphor or track team, okay, develop a software, develop a system to make sure the users understand about the prediction, observation, monitoring, visualization. Okay, this is the ending what we want. All right. So the process will be recycled, okay, to the data collected again. Maybe they want to get a very good result, so the data should be big. So they base on the variety of data, velocity of the data, right? They rate and then they collect again. They do the data cleaning, data processing again, and then they do some statistic methodology to increase the accuracy. They enhance the data from machine learning to deep learning to do the good predictive analytics. Okay, so they do it this recycle until they get a best result. Until they get a best result. So now, okay, when we do this process, the task, involved is a data collection, okay, data preparation, data training. So we need a training model. Okay, the training model that you are going to emphasize here is what? Is a machine learning or deep learning. And then analysis evaluation. Okay, we have a big data analysis, for example, the specification, okay, the sensitivity, all right, the accuracy, the preciousness of the data. And then the surf model, and towards the end, okay, we want to retrain the model. That is not ending, all in the continuous process, in the cycle process, to make sure that the analysis will be good, okay, will be good predictive, okay, will be good analytics, all right? So now, this is one of the example. Now we are in the COVID-19 pandemic, all right? So there is a few, okay, relevant, okay, people, okay, that you can categorize the people, whether the people is true positive or false positive or false negative or true negative. This is a common activities what we do. All right, we want to find the sensitivity and specificity of the disease, okay, from the COVID-19. For example, here, okay, the green color is how many relevant items are selected. How many 6 people are corrective identified as having the condition. What is the condition? Is a true positive in terms of the false negative. All right. The other red color is how many healthy people are identified are not having the condition, not having the COVID-19. It's a false positive, all right, and true negative. So the ratio between true positive and true positive plus false negative is we call as a sensitivity, all right? And then the ratio between the true negative divided by true negative plus false positive is a specificity. This is an indicator to investigate whether the classification method, okay, the big data analytic, the machine learning, okay, or deep learning method that you're using is a good or bad. All right. So this is a indicator to find whether how many people help, okay, how many people help and how many people sick because of the COVID-19. Okay, so this is a relevant element. Okay, you can see here the graph that you are going to develop is based on the ABC, the red color. Okay, based on the true negative, the sensitivity is a 100% sensitivity. All right, B is a most accurate, C is a 100% specificity. All right, so this is how we can say that the method is valid, okay, can be good or predictive or not. All right, so maybe Dr. Marina.
Yes, ma'am. So we have reached the time limit for today. So thank you so much, ma'am, for being with us and sharing all this information. We'll continue from here during tomorrow's session. So it was a very informative session, ma'am, and thank you so much for sharing all this with us. And to all the participants, if you have any queries that you would like to ask, you can post it in the chat box or you can ask it during tomorrow's session. So we'll be continuing the same session tomorrow at 5 p.m. I request all participants to join by 4:50 so that we can start at sharp 5. Also, please check your chat box because the feedback form link is given there. Kindly fill the feedback form within the stipulated time. Once again, thank you, ma'am. Thank you for being with us. Thank you all. So we'll meet you all tomorrow. Thank you.
Hello, ma'am. Hello.
Yes, any question?
Ma'am, actually, computing skill is very essential, isn't it, ma'am? Though we have mathematical knowledge, computing skill is also equally necessary, since we need to analyze and again we need to interpret, isn't it? So for that, computing is essential, isn't it?
Okay, based on the what we think, okay, because we are mathematicians, we are statisticians, so we think that programming is very important. Okay, computing is very important. Actually, the important is a root, the fundamental, the advanced is a mathematics. Okay, mathematics background and statistics background. That's why my student, okay, my student is a mathematician. My student is a statistics student. My student is based on numerical analysis, all right, background. So why they can be employed? None of my student jobless. None of my undergraduate project with me, and then a master student with me or PhD student with me, none of them jobless. You know why? Because when I give a skill, not just computing, their background, their mathematics is very good, and then they know how to use a software. Okay, in mathematics, we already open our student with the MATLAB, with the Mathematica, with the Maple, with the C programming, with Fortran. All right, so based on this, information, C programming at least, they know how to create a simulation, a computing. So in my case, I ask them, to do a basic need that they learn in the undergraduate, for example, C++. And then I train them to the open source software. All right, why? Because the industry out there, they're using open source. Okay, since they are very good in mathematics and statistics, they know how to train the data, testing the data, manipulate the data using SPSS software, using Amos, using PLS and so on. So they know how to integrate. This is very good. All right. Okay, since they can predict the data using a classification method, they start comparing. All right, they start comparing a method, and towards the end, they believe that they can go for this career as a data analyst and data scientist. All right, and then it's really inspired me because their salary is very, very high, compared to the engineers in mechanical engineering and so on. Why? Because nowadays, since we are COVID-19, everything is a data, analyzed from the data provider. It's very easy to get a data provider, especially in the industry, and then that's why they work in the industry. They help the industry. For example, AirAsia, all right. One of my students working as a data analyst at the AirAsia. There is no limited flight nowadays. They do so much on the analyzing the data. So that's why you can see most of my students, there is no jobless. Now they're aiming for the data analyst and data scientists, not because of the computing, not because of the programming, not because of the computer science, not because of they are back in the computer science, no, because of the mathematics background, very good in fundamental, in advanced, in the forecast, in the stochastics and others, numerical, analysis field, right?
Yeah, right. Right. Thank you, ma'am.
Ma'am, what about students from like other departments? Like we have like physics students, chemistry students who have done like very basic mathematics. So do they have a scope in this field?
All right. You can see here the qualification is not for chemistry, not for chemists, not for physicians, no. All right. They are for mathematics. Okay. All right, so there is not for other field. This is for more on the logic thinking, mathematical thinking, statistic thinking. All right. So and then machine learning. The learning and testing thinking. All right. So however, if they are from chemistry, they can use this knowledge for their field. For example, nanotechnology. When they have an image, FEM, SEM in images, very fine image. All right, 10 power negative 9, not just a molecular level, is a nano level. So you can see, okay, they can use machine learning, deep learning to analyze the images. Since they are looking for the web lab, you know, web lab, now we are COVID-19, okay, we are not regular go to the chemistry lab. So in this case, okay, we getting a data from the lab and analyze the data. Since the data is, you know, the variety, the velocity of data is very high, all right, every second. So they start using machine learning to interpret the data. So you can see that machine learning quite familiar in the biotechnology, chemistry, physics, all right. So means that people, mathematician and statistics expert with the machine learning and deep learning or big data analytics, they can work with them, okay, in the different area, for example, nanotechnology area, biotechnology area, sustainable energy area, and so on. All right. So we are considered as a root, right, of their field.
Oh, thank you, ma'am. Thank you.